Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This is an example question of type 1 and type 2 errors of Poisson distribution. An important advice, we should be soft to everyone. This question is from November 22, paper 6-2, question 4. The number of faults in cloth made on a certain machine has a Poisson distribution with mean 2.4 per 10 meter square. So 2.4 per 10 meter square mean. An adjustment is made to the machine. It is required to test at 5% significance level whether the mean number of faults has decreased. So H1 is lambda less than a lower tail test. A randomly selected 30 meter square. For 30 meter square, lambda is 7.2. And the number of faults is found. State null and alternative hypothesis for the test. So this is very simple. H0 is lambda is equal to 7.2 and H1 is lambda less than 7.2. This means lambda has decreased, lambda has not decreased. Find the probability of a type 1 error. This is very simple. Probability of type 1 error is the probability of critical region. So you have to use trial and error method. Now you have options. You can try with 1 or 2 because 0 is always in critical region. This is the first value. So let's try with 1, x1 or 2. So probability x less than equal to 2 because it's a lower tail test. So you have to find this probability and you have to compare this with alpha percent. In order to save time, I'm just checking the results. So x less than equal to 2 is 2.55%, which is less than 5%. So 2 is in critical region. Now try 3. Let x be 3. So x less than equal to 3 is probability 2.55% plus probability of 3. And this answer is 7.19%. This is greater than 5%. The probability of critical region is 5% and probability of 3 is 7.15%, 19%. So 3 is not in critical region. Therefore, critical region is 0, 1 and 2. So probability of type 1 is probability of critical, which is probability of 0, 1 and 2. And this answer is 2.55%. Can write this as 0.0255, 3 significant figures. So this is the way to find probability of type 1 error both in binomial and Poisson. Now, next point, exactly 3 faults are found in the randomly selected 30 meter square of cloth. Carry out the test at 5%. So this is very simple. You already have done this in previous part. This is 5% and 3 is not in critical region because this probability is 7.19%. You have to mention as 7.19% is greater than 5%. Probability of greater equal to 3, less than equal to 3. So 3 is not in CR, hence except H0. Since 3 is not in critical region, so except H0, that is sufficient evidence that lambda, we are accepting this, insufficient evidence that lambda has decreased. You can write in this way, or you can write sufficient evidence that lambda has not decreased. But it's better to write this thing. When you are accepting H0, then mention this thing, insufficient evidence that lambda has decreased. You can write in any way. Insufficient evidence that lambda has decreased. Later, a similar test was carried out at the 5% significance level using another randomly selected 30 meters square of cloth. Given that the number of faults actually has a Poisson distribution with mean 0.5 per 10 meters square. So this is the new lambda. But this is for 0.5, 10 meters square. For 30, it should be 1.5, I guess. We need probability of type 2. Probability of type 2 is the probability of accepted region. And accepted region is x greater equal to 3, because 3 is not in critical region. And critical region is x is 0, 1, 2. So accepted region is greater equal to 3. So 1 minus 0, 1, 2. So 1 minus e power minus 1.5, 1.5 power 1 over 1 factorial, 1.5 square over 2 factorial. So this is the probability of type 2 error. 0.191. Make sure you give your answer up to 3 significant figures. Hope this lecture will help you to understand the type 1 and type 2 error probabilities in Poisson distribution. Good luck and Allah Hafiz.